So, Coach, I know we've discussed a few times before, but still, like, can you give us a short introduce of yourself?
Oh, I'd be happy to. My name is Schexnayder. I'm a. I have several lines of work. I do a lot of consulting work, primarily in training design and biomechanics in a lot of different sports. I also do a lot of rehab-based work, and I'm a former track and field coach. I've been coached collegiately and internationally for quite a long period of time. So basically, that's a rundown of my activities.
Nice, nice, nice. So, today I kind of want to focus on like sprinting. So, the first question would be like, there's a lot of coaches utilize like the Charlie Francis like short to long approach. So, first of all, I kind of like explain a little bit about what is like the short to long approach and your thoughts on this.
In a short to long approach, what you're doing is with the speed work that you do over the course of time, from the beginning of training up until the competitive season, the workouts, the run distances employed tend to get longer. So that's the name of the short to long. You begin short and you finish with longer efforts. So if you were going to do a short to long approach, you would begin the training of general preparation, working on accelerations, which are, of course, a very short form of speed. You would then progress on to an emphasis on maximal velocity work, which, of course, would be a longer form of speed. And then you would progress on to speed endurance work, which, of course, would be an even longer type of speed. This doesn't necessarily mean this is all you do, but this is how you would tend um, to progress the speed training itself, the run speed training over the course of time in the preparatory phases of training. This is my personal favorite, honestly, and this is widely accepted. It's not traditional. For years and years. It was a non-traditional model. Now it's become more of a popular model. It's probably become the dominant model now because more coaches are using it, and also it's kind of the curriculum that's taught in a lot of our American coaching education programs. But in this particular model, there are a lot of reasons why it's effective. The first reason is that it enables you to do speed from the very beginning. You know, if you're dealing with an athlete and that speed is very important to that athlete, it's important that they do speed in the very earliest stages of training. But if you're doing speed in the very earliest stages of training, there might be some risk involved. So if you keep the sprints very short, you can sprint on the very first day of training with no concern over injuries because risk doesn't really occur until the sprints get quite a bit longer. You're not likely to pull a hamstring until you're sprinting at least distances of, say, 35 or 40 meters. So that's one advantage of this particular system. That particular system enables us to employ speed in a safe way from the very beginning of training. This system also makes sense from a pedagogical standpoint, from a teaching standpoint. The acceleration work enables you to address speed early and it prepares you to run fast. This work also drives a lot of nervous system adaptations that will be useful later on. Then once you condition the body to run fast with acceleration work, you can teach the body to be faster using the max velocity or the speed development work. So the speed development in this situation, the max velocity work, uh, genuinely improves your speed capabilities. Then you move to the speed endurance training, which takes the speed improvements that you've made and makes them stable, makes them permanent because of the coordination gaining benefits of the speed endurance. And the third reason why this is a very good system is because extremely high levels of acidity, glycolytic distress, we used to say lactic acid, make it hard to train speed, make it hard for speed improvements to take place. In this particular system, you're doing your acceleration and your speed work first before you get into the speed endurance work where the analytic, the anaerobic work where the glycolytic work produces those high levels of acidity. So it makes sense from the standpoint of biochemistry as well. in that we're actually accomplishing a lot of our speed development before we get into situations where we're going to have extremely high levels of acidity. So in short, that's the system, and those are the advantages of it and the reasons why you would tend to employ it.
Nice, nice. So besides like the short to long approach, there's also a long to short approach. So I know it's at like the name, but how exactly is it different with the thing you mentioned before, like before?
Well, a long to short approach is just that, meaning that rather than start with shorter efforts, you tend to produce longer efforts in the early stages of training, and you eventually progress to faster and faster and shorter things. In the long to short approach, typically speed is not truly addressed in the earliest stages of programming. In many situations, it's more of an approach of tempo work or things of that nature. Then you progress to things that are faster and shorter. Then you start to work on genuine speed and acceleration work later. So ultimately, you're starting with longer efforts and you're finishing with shorter efforts. So you're not only working from long to short, but in some ways, you're also working from slower to faster. Now, this system of training was the commonplace system of training for a very long time. And because of that, it still exists today. I don't consider it personally as effective or as efficient for several reasons. First of all, it doesn't allow you to address speed early. To address speed using long sprints in early phases of training is extremely dangerous. So typically, the work has to be slower in the earlier phases of a long to short type of program. Secondly, the nervous system adaptations that help us to improve speed, but also improve strength and other qualities, we want to have those earlier. In a short to long system, the nervous system gets stimulated early. Therefore, the training from that point on is more effective. In this system, the long to short system, the nervous system is not stimulated early. So the improvements that are taking place early come much slower and they're more difficult to come about. And then finally, there's also a little bit more of a chance of injury risk here as well, because of the fact that you are doing longer efforts. A lot of times, soft tissues don't react well to longer efforts; they tend to tighten up. So later, when you come to do the faster efforts, then a lot of times you will end up with injuries because the tightness that was produced in the longer efforts early in the program is a problem when it comes time to do the fast stuff. And then, of course, I guess one other thing would be the acidity. We're trying to delay that acidity as well. So that being said, I personally don't consider it a very good system. Although there are coaches who still use it, it was the prevalent system for a long period of time. But I think that almost all of the science now is pointing more toward the effectiveness of the short to long uh, system. Now, most coaches who employ the short to long system don't just do short things, meaning that they'll do some easy tempo work or some slower tempo work early um, um, while they're doing the acceleration work. So they may have an additional day where they might be doing longer efforts, but the actual progression of the speed stuff is short to long. So just because we have a short to long approach doesn't mean that the only running workouts that are being done are acceleration type workouts in that first stage of training.
Cool. So Um, is it kind of like how the American like track season works? At the beginning in the inside, like indoor season is mainly like 60 meters, and when it comes to outdoor season, there's mainly like 100 meter and 200 meters. So is it like when before the like before the indoor season, they mainly work on shorter than like 60 meter, or like mainly focus on 60 meter, and outdoor they mainly train for 100. Is it kind of the same with that?
Not quite. I think that it's not so much about training for a race as much as developing the qualities. So it's very difficult when you're competing regularly to make true speed improvements because of the fact that you have had, because a lot of times the body's beat up, you have acidity situations going on and so forth. So to try to truly develop speed in season is very difficult. So most track coaches will take the approach of developing developing speed, improving speed before the beginning of the season, and they'll start to look at the season as a time to develop specific techniques and specific types of fitness that you might need for the different races at that time. Indoor is a very unique situation because indoor, often coaches are working on speed endurance. However, the speed endurance work doesn't really help indoors much because of the presence of the curves. Speed endurance is about maintaining maximal velocity for longer periods of time. And indoors, because of the curves, you don't ever get a chance to actually do that. But it's not wrong to do that at that period of time because that's what you're ultimately preparing for when you move to the outdoor season. So, in short, I think most coaches are not so much looking at preparation for specific races in the preseason time as much as they are developing acceleration capabilities and speed capabilities to a high level before they start looking at specific preparation for the events.
So they mainly like develop like those elements they need or the athlete need during the off season. And then what happens during the season, like Noah allows, it gets faster and faster when it comes to like the championship of Diamond League. How exactly did that work?
Well, keep in mind that we've developed our speed already. Now we're starting to show the speed. So what happens in season is that in many situations, the competitions themselves become the most critical workouts, meaning the athlete who runs the 100 meters incredibly fast in the Diamond League final or late in the season. A lot of that has to do not only with what they did in the preseason, but the series of meets that they've run up to that point. And again, the competitive loads are typically very high. Internal damage to tissues is very high when you run very fast. So a lot of times the actual meets themselves tend to be the most critical form of training in those situations. Now, this is not to say that nothing else is done, however. Most athletes will continue to review acceleration development and short speed during the in season. The reason being to keep the nervous system stimulated between those high intensity efforts. And if the competitive schedule does not have frequent meets, if there are long breaks in the competitive schedule, then you'll have to subject the athlete to really high velocities and intensities in season in order to maintain that fitness. On the other hand, if the competitive schedule is very dense and the athlete is competing extremely frequently, that might not be the case.
So it's like jumping, like we discussed before. It's like jumping when when we are able to like hit maximum like plyometric, we probably still need to adjust like uh the elements like uh easier plyometric between those days, right?
That's correct. You're training the nervous system at a very, very high level on the meet days, on the competition days, but the competitions are spaced apart, typically by at least a week. If this is the case, then the nervous system in the meantime is very likely to become stagnant. Rate coding capabilities, meaning the electrical properties of the nervous system and the stimulatory ability of the nervous system, is likely to drop. So, by doing more remedial forms of speed like acceleration or the more basic forms of plyometrics, as you said, we maintain stimulation. So, that's an important component in season as well, is maintaining stimulation. Also, keep in mind that the adaptations you produce in the preseason are still taking place. Just because you quit doing something doesn't mean that the adaptations are continuing. So, a lot of these adaptations are long term adaptations. And when you see an athlete who's improving their speed in season, quite often it may not be because of the speed development that they're doing in season. It's because of the speed development they did in the preseason that is just now starting to show its largest benefits.
Cool. I want to dive a little bit deeper into this. Uh, in a few years ago, I saw the Nick Winkelman did a conference at the NSCA that, and he discussed about like periodization and about like when they when he was still at Exos, they're gonna train like 6 to 8 weeks for the combine, and he mentioned that after they train 6 to 8 weeks, athlete needs to rest like 6 to 8 weeks to peak. So how exactly do like, or is there a certain time frame that we can like calculate it, or we can just know that when are we when are our athlete gonna peak after like a long periods of like training?
It's a lot more complicated than that, and there's not a firm formula. Just about every coach, in order to peak an athlete or to get the best performances, does two things. They maintain their intensity in order to preserve stimulation of the nervous system, and they drop their volumes in order to increase the rest component and such. So that being said, when this actually takes place, you start to look at it maybe 6 to 8 weeks out, but everything doesn't drop 6 to 8 weeks out. To do so would produce extreme levels of staleness, extreme levels of non-stimulation in the nervous system. So there are certain things that have to continue. My personal philosophy, as far as peaking is concerned, is not so much to drop your volumes, but to drop your densities, meaning things that you normally might do, say, 3 times a week, now you only do twice a week. Things you would normally do maybe every 10 days, now you do them every 2 weeks. Things that you might only do once a week, now you do them every 10 days. I'm not a big fan of dropping the volumes per unit. For example, if it takes, say, 6 to 8 acceleration runs to produce the levels of stimulation you need, and you drop that volume because it's a peaking time, in that situation, you're not going to get the neural stimulation. Therefore, so it's not about cutting things across the board. So I agree with him that 6 to 8 weeks out is when you start to put some concern to the peaking process. But I don't think that it becomes a matter of basically resting everything for 6 to 8 weeks and expecting something great to happen. In fact, very seldom will that happen. And also, there are tremendous differences between men and women also. Women are typically superior creatures from the standpoint of work capacity and elasticity, and where men tend to do a little bit better on lower volume types of peaking and a little more rest with minimal stimulation. Women typically don't do nearly as well with that, and women typically I've found that you kind of have to keep working significantly harder, or they'll be very flat and not perform well in critical competitions. Um, so take again, so it's to make a long story short, I wish I could just give you here's the recipe, but it just isn't that simple. And a lot of it also has to do with what's going on with competitions leading up to the peaking situation as well.
Cool. No worries, man. No worries. So, uh, the next thing I want to ask is like, um, it's not about like the training volume or intensity. It's about how to set up for a or for a start for sprinters. Because
Mhm.
like when I train myself or like I train my athletes, it's kind of hard to like get every athlete to feel what they need to feel at the block start.
Mhm.
So is there a
So
certain thing you're gonna look at when it comes to like setting for the block start?
yeah, there are some certain markers that I think are important and non-variable, meaning that they're firm, things that you must do there. The first one is the pad distance from the starting line. When you look at the front pad, 2 feet from the starting line is correct, and the back pad 3 feet from the starting line. And when I say feet, I mean the length of your feet anthropometrically. Okay, so the length of your feet. So 2 and 3 would be the block spacings. Many sprinters tend to get closer than that, but it typically causes problems. I do understand that there is a common sense type of mentality that if I'm closer to the line, I'm closer to the finish line also, but those bunch positions don't seem to work very well. So you give up a little bit to be 2 and 3 behind the line. When you set up in the blocks, I insist that the athletes back into the block. I don't want to see them put their foots on the pedals. I want to see them back in, get on their knees, and then put the feet solidly against the pedals. And then they can position their arms and shoulders. When they are set, before they come to the set position, I like one knee down. I want to see the bottom of the foot, the ball of the foot against the pad firmly. And I want to see the shoulders directly over the hands and the hands on the fingertips. I'm not saying that some people haven't run fast with flat hands or knuckles on the track, but you're better off with fingertips. It's worth a couple of hundreds of seconds, and sometimes that's very important. So again, the shoulders directly over the hands at that point, and the head is just hanging net neutral. Now, when you come to the set position or coming to the set position should be a very simple movement. When you come to the set position, there's only two key things that should happen. One is that the hips rise, and the hips should rise to a point higher than the shoulders. So if the hips aren't higher than the shoulders, they aren't high enough, and that's a very common mistake. Lots of athletes don't bring the hips up high enough to use the hip extension, the excursion, the complete excursion of the hip extension in the block start. The other thing that's important to watch for is when they come to the set position to make sure that the feet, the heels, are solidly against the pads. So there should be, when you look at the top, the higher part of the foot, closer to the heel, you should not see a gap between the pad and the foot. So therefore, when they come to set, if there's a gap there and the foot has to push back against the pedal, the time it takes for the foot to touch the pedal is wasted time. So we want to make sure that the feet are solidly against the top edge of the block as well as the bottom edge of the block. So those are the key markers. Also, when you come to set, I guess we should say something about the upper body of the shoulders. The upper body and shoulders don't move, meaning you had the shoulders above the hands in the preliminary position. When you come to the set positions, the shoulders should be still directly over the hands. The head that was tilted downward and hanging now is in perfect alignment with the back because you've brought the back angle up to match the head angle. So now you see the spine and the head in line, which is something else that you want as well. So in short, that's basically it. So the thing I've always and the thing I always point out to coaches is, if the shoulders are over the line like they should be, then you only have two variables, the block spacing and the height of the hips. It's a closed system. There aren't many variables there. So if you have trouble getting your athletes into positions, then either they're not using the correct block spacing, the 2 and 3 feet, or the hips are not positioned at the correct height. Those are the only two variables that there are.
Cool. So, I once saw like not allowed to discuss this with other sprinters that when before he turned pro, the back when he's in the block start, the back of his leg like didn't feel tension before he turned pro. But after he turned pro, the coach asked him to put like you mentioned, put the heel on the pad. So personally I tried this before, and when I put the tension on the back of the leg, it's gonna help me like project my body in a much better angle. Like what makes the difference from just putting the tension on the back of the leg makes us like have a greater angle to like project out.
Well, remember, first of all, every sprint start has two components, a horizontal and a vertical component. Obviously, the horizontal component enables you to run faster, but the vertical component is very important because this is what allows you to achieve body angle changes and proper postures later in the sprint. And it's always been my opinion that if there isn't any pressure on the back pad and you're not getting a contribution from that foot, then your angle of projection is typically going to be too low and there'll be a stumble. It might not be a bad stumble that really catches your eye, but it's enough of a stumble to prevent you from achieving good sprint mechanics later in the race. And if you watch really good starters, um, when the gun goes off, if you can go very slow motion with the video, one of the thing you always see is at the gun, you see the rear heel move backwards against the block. So what we're seeing is a short, quick push against the back block before that leg moves forward.
Cool. So, like I know, like sprinter, they always at the competition they always use like block start, but when they train, there's gonna be like falling start. There's gonna be like 3-point start. So why exactly do like or how why do we need those different starts since they're just when in the competition they only need like block start.
That's a good question. And the reason why you see all of these, there are basically two reasons why you see all of these different types of starts in training programs. The first reason has to do with the way we as humans learn skills. Motor learning research tells us time and time again that if you're trying to practice a skill, if you're trying to develop a skill to a high level, the best way to do it is not to practice just that skill, but also to practice small variations of that skill. So if you're looking at a block start, I would say, or a motor learning person would say that a 3-point start or a push-up start or a 2-point start or a rollover start, those types of starts would be subtle variations of starts. And because of that, ultimately you're able to, you know, you're making yourself a little better from the standpoint of adaptation. Remember, what's important in order to teach a skill is to challenge an athlete to some extent. So that's a way of challenging them, is to put them in slightly different starting situations. So the variety of these different types of starts, the subtle variations from the block starts that these different types of starts show, mean that they contribute to the eventual effectiveness and skill shown in the block start. And the other reason why you have these types of starts is a practical one. You know, if you have an athlete, for example, who is tends to push too flat in the early stages of acceleration, the last thing you want to do is put them in the blocks. You want to put them in a two-part situation where they have a chance to generate a more vertical component when they push out on that first step. And a lot of times it's just very practical. You know, if you're going to do a running workout, let's say a tempo workout or an intensive tempo workout, or maybe a speed endurance workout, and you're starting at different positions all over the track, it becomes very inconvenient to move blocks to all the different spots that you need for all the different athletes that you're coaching. So in those situations, we do those types of starts just because they're convenient and they don't require equipment, and they just make the workout go smoother and easier.
Cool. So like 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 you mentioned, there's gonna be falling start, there's gonna be rolling start, and and when it comes like block start, the short is gonna be over the hand. So personally, when I like train myself, when I push too much, my body's gonna project more vertically. But when I put my center of mass a little bit over or a little bit front side when I set up the block start, my body of angle is going to be much greater and it's much better degree. So why or like in what certain like extent or how can we balance between like a falling and pushing?
Okay, that's a good question. The I personally, when it comes to standing starts, am not a big fan of the falling start. At least as is commonly taught. Like when you're in a standing situation and you start to fall forward, if you wait until the very last instant before you're about to lose control, before you push out, typically you're going to push too low, you're going to push too flat, and you're going to push too late. So I'm not a fan, frankly, of the traditional falling start in that reason. I just don't see good starting mechanics in those situations. However, there is a small amount of, I don't like to say falling, but there's a small amount of rocking, so to speak, in every start, including the block start. If you take a video of a very good sprinter coming out of the blocks and you put it in very slow motion, when the gun goes off, you see three things. One thing that you see, as we've already said, is that the back heel pushes against the back pad. You see a very quick push against the back pad before the back foot moves forward to take the first stride. The other thing that we see is if you're looking at the front leg, you see the shin rotate forward. Normally in the set position, the shin is about 45 degrees. What you'll see is that the shin will rotate forward about 10 more degrees. The shin will rotate forward so that the knee is actually dropping down toward the track a little bit more. This is important because this is a mechanism that loads up the quadricep muscles for the push on the front leg. So every start has that to it. Every start has a little bit of a shin rotation involved in it, including 2-point starts and 3-point starts and 4-point starts and rollover starts and all those others. I would challenge all of your listeners to watch an athlete next time they do a standing long jump, just a normal standing long jump. If you pay close attention to an athlete doing a standing long jump, you'll see that their hips move backwards. Then the next thing that happens is their shins rotate forward and the shin angles change, become lower, become smaller as right just before they push. It's the exact same concept. So that 10 degrees or so of shin rotation loads the quadricep and allows a better push. So three things happen at the gun. You see the back pad move, the pressure on the back pad. You see the shin rotate a little bit. And the last thing you see is you see the hands rise. You know, you don't split your arms right away. You actually see the hands rise for an instant before the arms actually start to split. And that represents about a 300th or maybe 400th of a second investment. Yes, it's true, you're not moving forward during that time, but you are doing movements that are going to improve the quality of the movement later and into the sprint.
So, like you mentioned, the shin's gonna roll a little bit deeper. So, like is this the main reason that coaches discuss like standing long jump is going to help like accelerating besides the shin, or the shin angle is the main reason?
I don't think coaches say it much, but it definitely does, in my opinion. When I have an athlete that is struggling with shin rotation in the start, normally what I'll do is I'll have them do more standing long jumps because in the standing long jump, the shin rotation seems to be more natural and they can kind of get the hang of it there before they bring it back into their block start. Now, in the standing long jump, of course, it's not one shin rotating, it's two shins rotating, but it's still the same basic movement.
So besides like you mentioned standing long jump, is there other accessory work that you would do to help an athlete to achieve a betting start?
You mean meaning the shin rotation component of the start?
Yeah, or like the
Yeah,
projection of the angle.
just about any horizontal plyometric would do that. Standing long jump is the most basic, most remedial form of horizontal plyometric, but repeated double leg hops or standing triple jumps, any type of basic horizontal plyometric would serve that purpose.
Cool. So, mm, does that mean like since we're training sprinters, we should more focus on like horizontal plyometric?
No, not necessarily, because at maximum velocity, the vertical uh, pushing forces become dominant and more important. So there has to be both. And frankly, the horizontal things are typically easier to develop than the vertical things. So you normally actually have to work on the vertical components more and have more repetitions of vertically based plyometrics than horizontal ones. But as I said, to totally ignore horizontal plyometrics, that would be a mistake as well.
So can you like give us an example? Like how would you like put in like the horizontal like standing long jump into a sprinter's like training session? Would it be like for a warm up to set up for the start, or like accessory after sprinting?
Typically, I do it after sprinting because I like the complementary nature of it, and I also like the way it potentiates the weight training session, which typically comes afterwards. But if an athlete is having problems with their start, and I think standing long jump can make a point, then we'll do a few impromptu standing long jumps during the actual acceleration session. But that doesn't get them off the hook from doing more later in the session. So to answer your question, yes, possibly, but I normally do them afterwards.
Great. So I want to go back to like what happens in the season is uh like recently there's like there's a few sprinters, world like very famous sprinters like Noah Lyles or like other sprinters that they're gonna compete at the Diamond League or like the World Champ. So uh what happens for Noah Lyles is he got COVID like 2 years in a row, and he misses like a whole week of practice and still got nominated for like the 100-meter track team.
Mhm.
So after that week of like full resting and competing at like very high intensity of like 100-meter sprint, this he's probably gonna like rest like 3 weeks. So if it's you, what would you like put in, or like how exactly like the distance for like acceleration and the blocking start, how would you program it in like these 2 or 3 weeks?
That's a challenging situation, and I don't want to drop. I don't like to drop names or give specific things. I'm not saying what I think Noah Lyles should do in those situations, but ultimately, if you're going to be successful, you have to subject the athletes to more intensity, right? So the only way to prepare an athlete for an intense event like the 100 meters is to subject them to intensity in practice. However, in this situation, you have a scenario where an athlete's ability to recover has been compromised. So anytime I'm in a situation like this, I try to maintain the intensity of the training, but I decrease the density of the training, meaning that I drop the frequency of training, but I continue to train just as hard on the days when we actually do train. I think that it's a common mistake in these situations to drop the intensity of the training because of the illness or the injury or whatever the case may be. If you drop the intensity, well, you have forfeited the chance to do well. Ultimately, you have to be able to exhibit intensity in competition. To do that, you have to be able to do it in training. So rather than dropping the intensity, again, I would prefer to train less often to supply more rest and recovery in between the training sessions.
Nice. I'm sorry I put you in a hard position to answer this one.
No hard position. But I never like dropping names because I never want to be someone to come in later and say, this coach said that Noah Lyles should do this, where they start thinking his coaching is doing wrong or whatever. I try to stay out of those situations.
Yeah, yeah. So like in the beginning of our conversation, you mentioned like GPP for sprinters. So how exactly is like GPP and SPP for like sprint workout, and how would you like rotate those? Like is it like 2 weeks or 3 weeks?
The general preparation period for sprinters for me is either anywhere from 3 to 6 work weeks. It's three for athletes that have some level of experience. It might be up to six for athletes who are kind of beginners in that regard. And to me, the general preparation period is not a period of fitness. That's a change philosophically that I think we've seen over the last 30, 40 years or so. We used to think that general preparation was a time for fitness, a time of no speed training, no real explosive training, just get in shape, so to speak, just to train anaerobically, possibly aerobically. I don't view the general preparation that way. I view general preparation as a time to improve the nervous system's ability to activate muscle tissue. And you do this through power training. So in general preparation, you should see lots of short accelerations. Obviously, the long accelerations might be risky, but short accelerations aren't. So you should see lots of short accelerations, lots of basic level plyometrics, lots of weightlifting, Olympic lifts, with very light bars. The reason why light bars is because the bars would be fast, and that would be another good power development kind of tool. I also think that general preparation is a time when you start to get the body's hormonal systems improved. So this is why general preparation is also a time with a lot of circuit training in it, not on the speed power days, but on other days. So body weight circuits and medicine ball circuits and things of that nature become very important during that phase as well. So if you've accomplished that phase and done it correctly, at the end of that phase, you're going to find a nervous system that is capable of producing more electrical energy and stimulating muscle tissue more. And you're going to have a hormonal system, an endocrine system that is capable of allowing that athlete to recover from training and increase the effectiveness of that training program. When you move into specific prep is all about intensity. So it's about the intensities that you achieve. So in specific prep, what we're looking at doing is moving on to high intensity, maximal velocity types of work where we make the athlete faster. We're looking at moving to more high intensity plyometrics, so depth jumps possibly or something along those lines. And also the weight training program, the strength training program becomes more intense. That intensity might take the form of faster bars, it might take the form of heavier bars, but regardless, there's some type of increased intensity there. So again, that's the hallmark of specific preparation. It's how can you progress intensity. Remember, the intensity that you master in training is the level of performance that you can expect. Okay, so you can't expect a level of performance high if the intensities you achieve are low. Now, because of the fact that these high intensity training sessions are very demanding, very hard, you can't do them nearly as often. So, therefore, doing a high intensity session like once a week is typically all you'll do. So that means that in between those sessions, that's when we have to go back to the general preparation things in order to produce stimulation. So, in short, that's the difference between general preparation and specific preparation. In general preparation, you have very frequent doses of speed and power training of a moderate level. In specific prep, you have alternating doses of moderate level for stimulation, high level for fitness. Then you go back to lower level for stimulation, again, high intensity for fitness, and you alternate back and forth between those two peaks. That's what we commonly call in training a high-low model.
Cool. Just to clarify, you mentioned that uh 3 to 6 sessions of like GPP and you're gonna enter like SPP. Am I right?
3 to 6 weeks.
Oh, three, sorry, 3 to 6
Yeah,
weeks.
36 work weeks. Yeah.
Yeah. And after that it's like SPP and put some GPP into it.
The things you did in general preparation for speed and power will also appear in specific preparation. In general preparation, those things were the key training, the important training things. When they go to the specific preparation, those things are now things the athlete is accustomed to, but they serve as the stimulation between the higher intensity forms of training. So the things that you do in general preparation for speed and power, like basic plyometrics and light Olympic lifts and acceleration work, those never go away. In general preparation, they're the hard training. In specific preparation, they're the stimulation in between the hard training bouts.
So last thing, okay. So let's say in the off season after like 3 to 6 weeks of like general preparation and we hit like specific preparation and it during the off season, are you gonna rotate back to only do general prep or is it like specific prep and doing like general prep for just like you mentioned things you mentioned just easy or like recovery for them?
No, we never revert back to a general preparation phase again. So the phase as it was originally constructed, we never revert back to that. We're always moving forward. The only time there will be back training in a true general preparation philosophy is next year.
Cool. Love this. Love this. Thank you, coach. So for those who are
Very
interested
welcome.
in what we're talking about today, where can they reach out to you?
The best way to get a hold of me is through my website, sacspeed.com, SAC, the word speed.com. And you can email me directly through that website as well.
Nice.